Section 3.3 is called the conditional, and 3.4, which we're going to encounter next, is called more on the conditional. So both sections that we're doing today are on the same topic, so that works nicely. This is the third of the three types of connectives that we talked about, or compound statements that we talked about. One connective was and, another connective was or, and the third connective is if-then, and that's this section, is the if-then connective. So conditionals are compound statements that use the connective if-then. The symbol for them, which we saw this last time, is the arrow. It has P, arrow, Q. And sometimes we read this as if P then Q, but we also read this as P implies Q. Okay, like we read the arrow as the word implies. The antecedent or premise is the P part, the beginning part. And then the consequent or the conclusion is the Q part. And you use these all the time. You make if-then statements continually. So I will do an example of one. If my daughter does not come home soon, then I will call her. This is a conditional statement. There's an if part, there's a then part. If the first part happens, the second part's going to guarantee to be happening. This is what they work like. So just like we had done with the sections last time, we're going to be like turning them into symbols back and forth. The problem is, for us, that if-then statements are often stated in different ways that don't look like if this, then this. But they're still conditionals. So oftentimes, not all the time, but oftentimes we might see something and we actually need to rewrite it in an if-then form for it to make sense for what we do next. So that's what we're going to look at first. So these two statements are if-then statements, but you can definitely see there's no if and there's no then, right? So we have to be able to take what's here and to rewrite it. And sometimes there's more than one way to rewrite it. Sometimes there's not. But here's an example. It must be alive if it is breathing. Now, you do see an if in this one, right? I don't think there's even an if at all in the next one. But you do see the if, correct? All right. So we're going to start with the if. This piece right here should be written at the beginning if we're writing in an if-then form. So if you see an if there, it's easy enough to fix it. You just shift the language around a little bit. And we say something like this. If it is breathing, then it must be alive. That's not to say that the first statement is not fine. There's nothing wrong with how that's written. It's perfectly fine. And we do that all the time too, right? We say a statement like that all the time where we put the if at the end. But it doesn't change the fact that it's an if-then statement that can be rewritten in an equivalent form like this. Okay, so this is the first one. The next one doesn't have an if at all, so we can't use that sort of little trick and say, oh, I found the if, and let's just shift it around. This one actually says, a shopaholic has no self-control. Okay? So any ideas? We are going to start out with the word if. I'll give you that. Any ideas how you might rewrite this?
If they're a shopaholic and they have no control.
Great job. That's exactly right. If they, he, she, I don't care what pronoun you use in there, but whatever you're using, if they, we'll do that one since that's the one you said, are a shopaholic, then make sure that your pronouns match, right? If you use he at the end, right? Then they have no self-control. Does that make sense? Some other ones that you will encounter will be things that will say something like, I'll give you another example because I remember one coming up last time when people sent me homework questions. All I think it started out squares. All squares are rectangles. Okay, so it uses the word all, or it could use the word every or something like that. Okay? Any idea how you might rewrite this one in an if-then form? Yep, Kyle?
If it is a square, then it is a rectangle.
You're exactly right. So we just put the if at the beginning, and we take the first descriptive, and we say it fits into that category in some way. So that's a very good way to rewrite it. If it is a square, then it is a rectangle. Okay, what do we think? Is that all right? Okay. In order to use our truth tables and logic arguments, we often will need to make sure that it's in a discernible form to start with. That's why we're changing it into these if-then forms. Okay, as promised, the next thing we're going to look at then is taking these things that have symbols with them, these statement symbols, and rewriting them in one direction or the other. So this one starts out in symbols, and we're going to write it in words. So because I see an arrow, how is my statement going to start out? If. If. Okay, what is the P referring to in the way that it's set up? He trains dogs. So that's what comes next. If he trains dogs. What would we do next? Then. Okay, then comes our next piece, then. And now I have not just M, but I have the negation of M. So we're going to practice a little bit. What's M? Just M. They raise alpacas. So what's the negation of M? They don't raise alpacas. Right. Good job. Remember that from last time well. So then they don't raise alpacas. Okay, is that one good? Okay, let's try it the other direction now. Now we have a statement in if-then form, and we're going to turn it into symbols. It's a good idea to see where the statements disconnect and kind of like put some, some underlining and stuff in here. For example, I see my if and I see my then here. So I'm going to kind of isolate that those are pieces that are separating the other spots. So this starts out with, if he does not train dogs. So what will I do as a symbol for he does not train dogs? And then what? P. Right. So I've got the tilde for the not part because this is a negation statement. And P. Okay, so I have written the tilde P. What comes next? An arrow because it has the word then following it, right? Okay, it says then she has a ferret for a pet, or they raise alpacas. And I hope that you noticed, but if you didn't, the word or right here means I've got another connective. And actually over here is showing me exactly what connective it is. What is it? It's the V, that was mirroring our U when we were doing it inside of set theory, So it's an or statement with a V, so we're going to have a V showing up there. But it has to connect the two pieces that are here. This says she has a ferret for a pet. What's that? S. And then I've got the or. What else? M. For they raise alpacas. Now there's one more thing that you might not have thought to do, so I'm going to show you this right now. We will have parentheses around this. The if and the then are separating two different statements. The if part comes first. The then is all the things that follow combined together. So we have parentheses around these. Okay, truth table. So we're going to draw the truth table out, and then we're going to talk about why it actually works the way that it does. That's a little bit different order of how I did the last ones, okay? So we're going to draw just the two statement truth tables like we were doing before. So we have P and Q, and we have a column for the whole statement. So I have P, Q, and have P implies Q. You know what the P column is because it's always the same way. What is it? True, true. Oh my goodness, I don't have space. Let me shift this over here. False, false. And what does the Q column always say?
True, false, true.
Excellent. And we know that we can always get some points just by doing those pieces, right? Yeah. Okay. Here's the way the true-false implication statement goes. Just like with and statements and or statements, if you have two true statements, it's true. So that's a good thing to know. True is always true, no matter what statement I'm dealing with. True, false, my next line is actually a false statement. And the last two statements are true. Okay? So let's talk about the why. If a statement starts out true, so the one that I had written before, let's actually pull that up and I'll copy it over here so that I can kind of use it as a reference, this one. I'll erase it before we need the screen at the bottom. But this is where we were. If my daughter does not come home soon, then I will call her. Okay. So what happens in this statement is that if the first part is true, my daughter does not come home soon, then by default, the next part's also going to be true. The whole statement will work. So the true implies true should make sense, right? It is true that she will get called, okay? And likewise, if my daughter does not come home soon, it would not be true, the false statement, that I wouldn't call her, according to the way this is set up. So the second line should make sense as well. It's the bottom two lines that confuse people, okay? The bottom two lines say that the first statement fails to hold, that my daughter does not come home soon. So assume that she does come home soon. Well, what next? Well, the reality is we don't know. Maybe I called her anyway. I just wanted to talk to her on the phone while she was driving home. Maybe I didn't. We don't know. So our default is that the statement would be holding true because we don't have anything guaranteeing it to be false. So anytime a implication statement starts out false, it will result in a true statement at the end. Doesn't matter what happens next. False, true, false, false, there's true statement. It is equally likely that she comes home soon and I called her as is she comes home soon and I didn't. I can't guarantee that to be a false statement, so by default I say it's true. We trust the person saying it, that they're not lying. That's another way you can think about it, okay? All right, so let's actually do some truth value statements. What you'll remember from last time, I hope, is that when they give you what P and Q and R and whatever are, then we don't have to do an entire truth table, the big giant ones. We just have to do one line. So here they tell us that P and R are false and Q is true. So when they give you individual pieces that you know if they're T's or F's, you don't have to draw an entire truth table. So you're going to draw a one-line truth table with the symbols that they give us. Now, I realize they gave me in the description here P, Q, and R, but this statement on number 5 doesn't have a Q in it, so I don't need a Q in my truth table, okay? I really only need the P and the R. So I'm going to put in P and I'm going to put in R. And then moving from left to right, I have a tilde R first, so it will be helpful if I put that one first. It's not impossible if you put the tilde P first, but it'll be easier if you put tilde R first. And then we have the tilde P that follows on the right-hand side. I'm sorry, it's not tilde P. I take it back. I was thinking I had a tilde. Forget that. You don't need a tilde P column at all. Okay, so we need a tilde R. And then I need one that joins it all together, right? So I have tilde R implies P. Okay, according to what they gave us, P, is it true or false? False. R, is it true or false? False. Fabulous. Tilde R. True. That'd be true. All right. So now I'm going to go from tilde R back to P. This is what I was actually trying to avoid when I thought we had the tilde P statement next. Let me use a different color here. So we're going to go from this one back to over here. So that means I'm starting out with a true statement, and the ending result is false. What happens up there when I have a true and then a false? It's false. So the answer at the end here is F, and the truth value is that this is false. Six is more involved. First of all, I've got all 3 letters, so I'm going to use a truth table that has all 3 in it. So I have P, Q, and R. Now what? Tilde P is a good place to start, not just necessarily, well, you could do the part that's in parentheses first. It would be okay. So I don't want you to think that that's not possible. But I like doing the tilde P first here. Was it P? Yeah. Because it's just on the left-hand side. Okay? What else do I need? The part that's in parentheses. So I have Q and R. I don't need to draw the parentheses in there. What else do I need? Everything. That's right. Tilde P implies Q and R. Okay. First, does that make sense? Those column headers. We got to be able to get the column headers to make sense before we can proceed. Good. What is P? False. Q? True. R? False. Okay. Those are the given pieces. What is tilde P? True. All right, the next one wants me to do line Q, or column Q, and column R. And it's joining together with what kind of statement? And. So if you have a true, false, and you're joining them with and, is that statement true or is it false? It's false. You don't have to memorize these, right? You can always have them with you if you just want to refer back to them to make sure you're keeping them straight in your mind. There's nothing wrong with that. All right, the last thing we're supposed to do is to join them all together. So now I'm going from column tilde P to column Q and R. So I'm going this direction. So it's a true implies false statement, and that is false. It's the one from above. It's actually the same resulting at the end that I had just a moment ago. This is a false statement, so a false truth value. Okay. Leah, do you have a question?
Yeah.
Just ask, because you may have it and somebody else might too.
I'm still confused on the truth table, like
Mhm.
why the third column is the way.
The third row, do you mean the row?
Yeah.
This one right here?
No, I mean like the.
Oh, you mean this right here?
Yeah.
Okay, so the column, you meant column. So there's a couple things I can tell you. One option is that you could just simply go with it and just be like, just going to memorize it. I don't have to know why. I don't think that's a good answer, by the way. I'm just letting you know. You could do that. So for those of you who are like, I don't really care, just tell me what I'm supposed to do. This is right up your alley if that's what you're going to do. The reason, though, has to do with the fact that when we're looking at these implications, we're assuming that somebody talking to us isn't lying, right? So the example I had is if my daughter comes home, if my daughter does not come home, then I will call her. So we're assuming that if she doesn't come home, that calling her really happens. That's the first one, so true, true. And that not calling her wouldn't happen. That's the true, false second row. Okay, so those two are the ones that people are usually pretty comfortable with. Those make sense. The last two rows, though, are the hard ones. So the last two are saying, well, what if the first part doesn't hold? What if she did come home, right? Well, that doesn't tell us anything about the conclusion. It might be that I still call, and it might be that I don't call, which means that if I tell you she came home, but I still called her, you would assume that I'm telling you a true statement because you don't have anything to guarantee it's false. And if you came home and I didn't call her, you would again assume that I'm telling you a true statement because you don't have any reason to assume that it's false. So that's where we get the falses on the two trues, on the end of those false statement rows. Okay? Anything else before I switch slides? Okay. Last section, we talked about things called equivalent statements, and we ended with De Morgan's laws, and they created some equivalent statements. We can also check for equivalent statements with something called a tautology. A tautology is simply a statement that's true no matter what the truth values are. Okay? In essence, what it really means is that when I create a big old giant truth table, whether it's 4 rows or whether it's 8 rows or heaven forbid if I did 16 rows, the last column would all say truths. We haven't seen one of these yet. But if I did a truth table and the last column was all truths, all T's, that would be a tautology. Okay, it's true in every circumstance. I think I have 2 of them to show you. Yeah, I do. So the first one, how many statements do I have?
2.
2 statements, right? Remember, identify the different letters. There's only 2 different letters. So there's only 2 statements. And we talked about last time that actually fixes or determines for us how many rows we're going to have. I have 2 statements, right? So I have 2 squared or 4 rows. If I had 3 statements, I'd have 2 cubed or 8 rows, okay? So I have 4 rows. They are the same rows that we've been working with already today. I have true, true, false, false, and they oscillate. True, false, true, false. Okay, so those are going to always be the same. All right, what else do I need column-wise, column header, in my truth table? I need a tilde P, right? It's in there. It's going to need to be there. Now's a good time to put it in there. I need a tilde P. We'll fill in the number, the TFs underneath them in a minute. What else do I need?
Tilde P if then statement.
So I need the part that's in parentheses, right? So I have all the individual pieces done, and I need the part that's in parentheses next. So I have a tilde P, arrow, Q. Sorry, I don't need parentheses right yet, but okay. And then what will I need? All of it. Exactly. Okay, so I have tilde P, arrow, Q, and then I have another arrow with Q. Now, I do want you to realize that what this looks like right now, because we haven't had anything here that looks like there's an application, is it looks like I'm just playing with things, right? Imagine a puzzle, like a Sudoku kind of puzzle. It just looks like I've established some rules and I'm playing a game-ish, right? And it does. I promise we're getting to the point of where it's usable. We're just not there yet. We have to have the ground rules in place before we can make this usable and apply to actual statements. So it'll turn back into my dogs and alpacas and ferrets question, right? Where I had context eventually. All right, for now, tilde P. What's the tilde P column going to be?
FFTT.
Yes. Okay, is everybody good with that? Yeah? Make sure you're looking back at the right piece. Good. Now I need, and they're going backwards, tilde P implies Q. So I'm going to go backwards in my table. All right. So if I start with the tilde P in the row 1, I have a false true statement, which is true. It's a weird one. It's the one that we were talking about with Leah, but it's still a true statement. The second one is a false statement. That's also true. The third one is a true statement. Also true. The last one, fourth row, is a true false statement. That's the false one. Okay? Okay, we're not done though. Right, we have one more column. This is actually why I like to put the column headers in there too, because it kind of feels like we've done everything at this point. And if I have my column headers, I can remember that I still had one more to go. Okay, so we're going to go from what we just created, the tilde P arrow Q column, and then back to the Q column again over here. So I'm going all the way here. Okay, first row, starting over here, I've got true implies true. That's true. Row 2, I have true implies false. That's false. Row 3, I have true implies true. That's true. And row 4 is false implies false. True. Emma's right. It's true. Remember, those ones that start out false are automatically true. They're the weird ones. Okay. Now, I did part of the directions. The directions say construct a truth table for the statement. We did that. The last part says identify any tautologies. Look at my last row. Do I have all truths in it? No. This right here means that I do not have a tautology. So this is actually a really good example of when I would be able to give partial credit, right? Like let's say you messed up something inside of your truth table, and in doing so, obviously you created some kind of problem in the last column. which means you cannot adequately assess whether or not there's a tautology or not, right? I can go in and I can change the partial credit because you were able to answer that question based on your incorrect work, so we're not going to double penalize. Make sense? This would be an example. Okay, next one. How many statements do I have? Directions are the same, by the way. How many statements do I have? 3. How many rows will I have? 8. So I have 3 statements. This is 2 cubed or 8 rows. This is one of our larger ones, right? So again, I'd go in order. PQR. Okay. We'll fill in PQR in a minute. Let's just do all of our column headers now. What else do I need? I need a negation of Q. Good. What else?
The parentheses.
Part in parentheses. So I have P and the negation of Q. Ooh, somebody already said it. Then what? All of it, the whole thing. R implies P and tilde Q. Okay, you good? Column headers are important. Do you remember, because we've only done, I think we've only done one of these. Do you remember what I do in my P column when I have 8 rows? You got it right, Jasmine. 4 trues and then 4 falses. Good, so we'll start with there. True, 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 false, 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 and false. Perfect. What do I do in my Q column? Nope. That'll be my R column. There you go. Yeah, this one's the true, true, and then false, false. True, true, false, false. And then the R column is going to be the oscillating one, right? Just goes back and forth, trues and falses. True, false, true, false, true, false. That doesn't look good. Let's try that again. True, false. Good start. Tilde Q. So we're going to reverse row Q, which went true, true, false, false. So I'm going to do false, false, true, true, false, false, true, true. All right. The majority of the work is done. Maybe not the hardest work there is to do, but the majority of the work is done, right? Which means you've already got more than 50% credit on the problem. Good stuff. All right, now we're going to take, it says column P and column tilde Q. And I'm going to join them with what kind of a statement or connective? And. Yeah, this is an and statement. And when is an and statement true? When they're both true. Perfect. Both true. So we're just going to go across the rows. I have true, false. That's false. I have another true, false. False. True, true on row 3.
True.
And true, true on row 4. True. Now take a look here at the end. In the P column, what do you see at the end of this? All falses. Which means I don't really have to do a whole lot of work for this, right? If it's true when both of them are true, and the P column from here on out is all false, what does that tell me about the column I'm working in? They're all false after that. So I have false, 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 false. So and statements tend to work out pretty quickly because you're looking for so much of the repetitiveness that it's easy to identify when you don't have it. All right, our last one, our last column, sorry, let's delete that, is to take R and P and tilde Q, and we're doing a if-then statement. Okay, if-then statements are new ones. Remember, if-then statements are true when they say true, true, and they're also true when they start out false. Okay? So the first row says true implies false. That's my one false statement. The only way that it can be false, in fact. Now the next one starts out false. So false implies false is true. The third one is true implies true. True. Again, lines, if you're using lined paper, it's a lot easier to keep track of these guys. Row 4 is false implies true. True. Row 5 is true implies false. Right here. That one's false. Row 6 is false implies false. That's true. Row 7 is true implies false. That one's false. This is a little bit low. Let's just do this again. There we go. And then the last one is false implies false, which is true. Is this a tautology? No. Why not? It's not all true at the end. There's at least one, and there's more than one in this case, false things that are in the last column. So this is not a tautology. Okay, tautologies are less common than not a tautology. That should make sense. It's got to be awfully specific for you to get the trues all showing up in that last column. They don't happen that frequently, which doesn't mean you're not going to see them. It just means that if it was a random statement, you're not going to see them very much. Inside of a contrived environment, like my math lab, you're going to see them. It's going to happen, just not in every problem. Okay, a little bit more. Negation. The negation of P implies Q is P and tilde Q. That's the negation. Okay, remember negation means logical opposite. So let's think about my statement that I gave before. If my daughter does not come home, then I will call her. The logical opposite of that would be my daughter does not come home and I don't call her. It's that second line of the truth table. This one right, oops, sorry about that. This one right here. This is the logical opposite, the thing that absolutely becomes false. Right? Remember, if we're doing a negation flips the symbols. True turns to false, false turns to true. We've been doing that in our truth tables, right? We just take the column and we switch all the T's and F's around. Well, the only way I can switch this from being true to being false is this line right here that I've circled. The antecedent, the part at the beginning is the premise, or the antecedent is true, but the conclusion or the consequent is false. Okay? So this is the negation of P implies Q. So we're going to take an if-then statement, and we're going to write its negation. It's helpful, I still think, to divide the statements up so that we make sure we keep all the pieces in order and that we negate the proper things. So we see an if here. I don't see the word then, but it's basically here. Agreed? Okay. So the if and the then separate my statements out. One statement is Ella reaches that note. And the second statement is she will shatter the glass. Must be a very high note, right? Okay. So the negation that I'm trying to write, what does it do with the first statement? It keeps it the same. So take a look here. This P that starts out at the beginning is also P in the negation. It's not changed at all. It just it's preserved. So the first part stays the same. And we would say, we don't need the if. That doesn't make any sense anymore. I'm not creating an if-then statement. It's going to be an and statement. So it's going to say, Ella reaches that note. Okay. What happens next in the part that I've written as the negation? And. So we write and. And then what do I have to do to the consequent, the concluding statement? Yeah, I have to negate that piece of it. And so it will be she will not, or does it say she? Yes. She will not shatter the glass. Sometimes you'll see verbs changed a little bit. Like you could maybe look at it like it was a past tense thing and say Ella reaches that note and she did not shatter the glass. So don't be too concerned about the verbs changing from present to past tense. That's an okay thing to do. Yes, ma'am.
Anytime you're gonna negate an if-then
Mhm.
statement, will it always be and?
Yes, it will always be and. Correct. Okay. Yes, Luke.
So is that just something we need to know, that the negation of P, Q is P and Q?
Mm-hmm. Exactly.
It's just something we-
It's just a fact to do, yeah. And we justified why it worked, but I'm not going to ask you to justify it or anything in the future. There is justification for it, but yes, it's a fact that we would want to know. Okay, a little bit more in this section. We're going to write the conditional as an or statement. So I wrote the negation of the conditional, and it was an and statement. We can also take a conditional and we can write it as an or statement. It's not the negation, it's the original conditional. So that looks like this. So if we have P implies Q, that's my original conditional. The corresponding or statement is actually the negation of P or Q. Negation of P or Q. These are logically equivalent to one another, so you could put like an equal sign between them. These are equivalent statements, much like De Morgan's laws created equivalent statements. These are just statements that involved if-thens, not just ands and ors like that one did. Okay? So for example, if I were to go up here about the Ella one, let's just go back and take that one for a quick example before we do the one that's written here. If I used this over here and I wanted an equivalent statement, not the negation, I would take the first part, Ella reaches that note, and what would I do with it? I would negate it and make it a not statement. So this would say, whoops, sorry. It would say Ella does not reach that note. Okay. And then I would use what word? Or. Or, and then I would keep the second part the same. It remains unchanged from the original statement, which would say, or she will shatter. Or again, you could change to she did shatter. The verb tense can change to past tense instead of future tense like that. Shatter the glass. Okay, one last one to do then is the one that we were given to do for here. I've got an if-then statement. We're going to circle and sort of draw some lines like we've done before. So here's my if. Right here is where my understood then is. Correct? So it's semantics. That means we're just using the symbols and we're changing the words around. The statement itself sounds funny. If she doesn't, he will. But if you think about it, it kind of makes sense, right? If she doesn't do her homework, then he will do it for her. That's not what you're supposed to do. If she doesn't do the dishes, then he will do the dishes. If she doesn't pick up the kids, then he will pick up the kids. Makes sense, right? We just don't have the other pieces that sort of flesh out the if of what we're talking about. Okay, so we've got the if and the then. We're supposed to be creating a equivalent statement using the or connective. So what will I do with the first part? Negate it. So the first part says she doesn't. What's the negation of she doesn't? She does, right? She, will work better if I use white. She does. What comes next? Or. And what do I do with the last statement? Keep it the same. So it will be he will. She does or he will. That is the equivalent statement, right? Either she's going to or he's going to. That's what it's saying, which is exactly what we were saying in the if-then statement before.